We are now at question 10 of this CXC CSEC January 2014 General Paper 2 exam video solution. And in this question 10, we are given this circle with the center O, and inside the circle we have two chords that are parallel. This chord SK is parallel to this chord AF, and that's what we are told here. And SW is a diameter because it passes through the center of the circle, and we are given angle SAF. Angle SAF is this angle here. It is 54 degrees. And we are also given angle KSW. Angle KSW is this angle here, and that is 62 degrees. Now we are required in this question to find a few angles, and we are to give the reasons for our answer in each case. So this is a circle theory question. Now the first part wants us to find angle FAW. That is angle FAW. That's this angle right here. Let's call that angle theta and mark theta on our diagram. And so that's the angle that we want. Now this angle theta is a part of the angle that is subtended by this diameter. That is, all of this angle is subtended by this diameter. And the angle subtended by a diameter is 90 degrees. And therefore 54 degrees here plus theta will be equal to 90 degrees. So let's show that. And this is it. Angle SAW is 90 degrees. Angle SAW is 90 degrees. That's the total angle between these two sides is 90 degrees. And that is because that angle is subtended by the diameter SW. And this is it. The angle subtended by the diameter SW at the circumference A is 90 degrees. And we can isolate the triangle SAW to show that 90 degrees. And this is it. The total angle across here is 90 degrees because this angle is subtended by the diameter, and this angle is the angle at the circumference, and therefore 54 degrees plus theta is equal to 90 degrees. And to find theta, all we need to do is subtract 54 degrees from both sides of this equation, and this is it. And when we do this calculation, theta comes out to be 36 degrees, and so that's the answer. The angle FAW is 36 degrees. Let's move down to part 2. Now part 2 wants us to find angle SKF. That is angle SKF. That's this angle right here. Let's call that angle alpha and mark it on the diagram. And this is it. We're trying to find this angle alpha, angle SKF. Now this angle alpha is one of the angles in this cyclic quadrilateral. The cyclic quadrilateral, that is AFKS. This is a cyclic quadrilateral because the four vertices are all on the circumference of the circle. And when we have a quadrilateral in a circle with all four vertices on the circumference of the circle, that quadrilateral is called a cyclic quadrilateral. And the opposite angles in a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. So let's show that. AFKS is a cyclic quadrilateral, and we can show that on the diagram. And this is it. AFKS is a cyclic quadrilateral, and these two angles are opposite to each other, and so they are supplementary. They add up to 180 degrees. And that's the basis on which we can calculate alpha. And this is it. Angle SAF plus angle SKF is equal to 180 degrees. And that is because opposite angles in a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. And therefore, we can write 54 degrees plus alpha equals 180 degrees. And to find alpha, all we need to do is subtract 54 degrees from both sides of this equation. And when we do that, this is the result. Alpha is equal to 180 degrees minus 54 degrees. And when we finalize that calculation, alpha becomes 126 degrees. And therefore, the angle that we want, angle SKF, is 126 degrees. And that's the answer for that part. Let's move down now to part 3. Now part 3 wants us to find angle ASW. That's angle ASW. That's this angle right here. Let's call that angle beta and show that angle on the diagram. And so we're trying to find this angle beta. Now, beta forms a part of one of the internal angles between these two parallel sides. These two lines are parallel, and this angle and this angle are referred to as the internal angles between the parallel sides. These two parallel sides are connected with this line, and the angles formed here between this parallel side and this line and this parallel side and this line are called the internal angles. And the internal angles between parallel lines are supplementary, meaning they add up to 180 degrees, and that's the basis on which we can find the angle beta. But let's show that on the diagram, and this is it. These two parallel lines are connected by this straight line, and therefore this angle across here, the total angle across here, and this angle 54 degrees across here are referred to as the internal angles, and the sum of the internal angles add up to 180 degrees, and so we can write that angle FAS, that's angle FAS, that's this angle here, which is 54 degrees, plus angle KSA, that's angle KSA, that's the angle on this side, equals 180 degrees. And that is because the internal angles between parallel lines are supplementary. They add up to 180 degrees. These angles are also sometimes referred to as the U angles because the parallel lines along with this line forms what some might refer to as a U. And another way of saying this is that the U angles between parallel lines add up to 180 degrees. In any case, the angles are supplementary, and we can therefore write this 54 degrees from here plus the sum of 62 degrees and beta from here add up to 180 degrees. And to find beta now, all we need to do is subtract 54 degrees and 62 degrees from both sides of this equation, and this is it. Beta will be equal to 180 degrees minus 54 degrees and also minus 62 degrees. And when we do that calculation, the result is 64 degrees, and therefore this angle beta, angle ASW, is 64 degrees. And that's the answer for that part of this question. And that's the end of part A. Let's move down now to part B. Now in part B, we are given this diagram, and it is a diagram showing 3 points P, Q, and R, and we are told that there are 3 points on horizontal ground. And in this diagram, this line with the N on top represents the north direction, and so this line as well represents the north direction. And so it is as if we are looking down at the triangle PQR from above. We are also told that the distance PQ is 120 kilometers and the distance PR is 150 kilometers. Additionally, we are told that the angle QPR is 23 degrees, and that also is shown on the diagram. So let's go to the questions. Now the first part wants us to calculate the distance QR. That's this distance across here. And to calculate the distance QR, we have to work inside this triangle. But this triangle is not a right angle triangle, and therefore we cannot use any of the three trig ratios, sine, cosine, or tangent. We have to use either the sine rule or the cosine rule. And in this case, we cannot use the sine rule because in order to use the sine rule, we must have a known side and a known opposite angle. And this actually is a typical case for the use of the cosine rule because we have two known sides and a known angle between them. And so to find the distance QR, we will use the cosine rule. And just to remind us of the cosine rule, this is it. When we have two sides and an angle between those two sides, the side opposite the angle A will be such that A squared will be equal to B squared plus C squared minus 2 times BC times the cosine of the angle A, which is opposite to side A. And that's the cosine rule. And if we apply this cosine rule in this triangle, we will see that QR squared, which is the side opposite the 23 degrees now, will be equal to this side squared plus this side squared minus 2 times this side times this side times the cosine of the angle between these two sides. And that's the cosine rule. And when we calculate the values on the right hand side with a calculator, the result is this, 3761.83. And to find QR now, all we need to do is take the square root of both sides, and this is it. QR will be equal to the square root of this. And when we calculate that value, and that is correct to 1 decimal place as was requested by the question. And so that is the answer. Let's move down to the next part. And we are now asked to find the area of this triangle PQR. Now, this triangle is not a right angle triangle, and this is a case where, again, we have two sides and an angle between those two sides. And when that is the case, we can use the trig formula for the area of a triangle. And we are going to call the area of that triangle AT, and let's look at the trig formula for the area of a triangle. When we have a triangle with two sides and a known angle between those two sides, the area of that triangle can be calculated using this formula. That is half the product of the two sides multiplied by the sine of the angle between those two sides. And this is it. And if we apply this formula to triangle PQR, we see that the area of triangle PQR becomes equal to half of the product of the two sides, that's the 120 and the 150, and the sine of the angle between the two sides, which is 23 degrees. And so the area of the triangle is equal to half of 120 multiplied by 150 multiplied by the sine of 23 degrees. And when we use our calculator to calculate that value, the result is 3,516.6 kilometers squared, correct to 1 decimal place. And that's the area of triangle PQR. Let's move down now to part 2. Now, part 2 tells us that the bearing of P from Q is 252 degrees. Now, bearings are angles in the horizontal plane which are used to measure the location between places. And if we want the bearing from one position to another position, we have to measure that bearing at the from position. And the bearing at the from position is the clockwise angle from the north direction to the line connecting the two positions. Let us say I wanted to demonstrate the bearing of P from Q, which we are told is 252 degrees. I would have to stand at Q, which is the from position, face north, and then turn to the right to face P. When I'm facing P, it means that I would have turned from the north direction 252 degrees to face P. And that would be the bearing of P from Q. So let's show the bearing of P from Q on this diagram. And this is it. That angle is the bearing of P from Q. That's a clockwise angle from the north direction to the line joining Q to P. That's the bearing of P from Q, and we are given that angle is 252 degrees. And now we're asked to calculate the bearing of R from P. So for the bearing of R from P, P is the from position, and the bearing must be measured at the from position. And so it is a clockwise angle from the north line at the from position, and so it's this angle to the line from P to R. And let's call that angle theta and show that bearing angle on the diagram. And so this is it. This angle theta is the bearing of R from P. It is a clockwise angle at the from position from the north line to the line joining P to R. Bearings must be measured at the from position. And so we want to find this angle theta. Now, to find this angle theta, it would be useful if we could find the angle between this north line and this line here. And in that case, theta would be the sum of this angle here and the 23 degrees angle here. But let's call that angle alpha and show it on the diagram. And if that is the case, it means that theta would be equal to alpha plus 23 degrees. And therefore, we need to find this angle alpha. Now, this line and this line are parallel lines. These are the two north lines, and they are parallel lines. And these two parallel lines are connected by this straight line. And so these two angles, this angle and this angle, are the internal angles between these two parallel lines. And the internal angles between parallel lines add up to 180 degrees. And therefore, we know that this angle and this angle add up to 180 degrees. Let's call this angle beta and show it on the diagram. And so this is it. Beta plus alpha add up to 180 degrees because beta and alpha are the internal angles between these two parallel north lines. But now beta will be equal to 360 degrees minus 252 degrees because the total angle in the circle around this point is 360 degrees, and we can therefore show that beta is 360 degrees minus 252 degrees. And when we do that calculation, it comes out that beta is 108 degrees. So let's show that 108 degrees on the diagram. And so that's it. And so we can come back to this formula and say that alpha would be equal to 180 degrees minus 108 degrees. Alpha comes out to be 72 degrees. And now that we know that alpha is 72 degrees, we can proceed to calculate theta, which is the bearing that we want. So let's show alpha on the diagram and then use that 72 degrees that we know alpha is now to find theta. And this is it. Theta will be equal to 72 degrees plus 23 degrees. So let's show that. And this is it. Theta is equal to 72 degrees plus 23 degrees. And when we do the calculation, the total here is 95 degrees. And so we can write our bearing theta. It is 95 degrees. But bearings must be written with 3 digits. And so we put the 0 in front of the 95 degrees. And that's the answer for part B of this question. And that's the end of question 10. And we'll do question 11 in our next video. See you then.